So here's the graph from part one of our analysis task. And just to remind you, was the flow of water out of the shower into a bucket, and we measured the volume of water in the bucket compared to time. And it formed a linear graph. And the question I have for you is the rate of change increasing, decreasing, or constant? Now, you'd be forgiven for thinking that the answer is increasing, because after all, the graph is going left to right, upways, right, which is increasing. The graph is increasing, that is true, but the rate of change is constant. It remains the same all the way through. I hope that makes sense. So there's a difference between increasing in regard to the graph and increasing in regard to the rate or the gradient. So a constant gradient means that whenever I look at the rise over the run, whether it's over a small section of the graph or a large section of the graph, the value is always the same. The ratio, if you like, of rise to run, or the calculation of rise divided by run, is always the same. This is my function. I use slightly different values to you guys, so you might have had something slightly different for your part one. But you can see that a linear graph has a very specific value in front of the t, in this instance, because it's v and t, and that value is the gradient. So whenever I put in a value for t, I multiply it by the gradient, and that gives me the value for v, which kind of makes sense because this is the rise and this is the run. Okay, so what you are going to do, well, here's the section summary here, that basically if it's got a constant flow rate or constant rate of change, then you're going to be producing a linear function for the reasons I've just gone through. So what you need to do now is just two questions, questions 7 and 9. They are very simple word-based problems, and you simply need to try and pick out the rate of change from these two questions. Shouldn't be too tricky. You just need to think of what would be the rise in this question and what would be the run. And then the rate will be rise over run. If you have a look at it, pay per hour, that kind of gives it away, right? If it's rise over run, then you've got y per x. So the pay must be like the y, and the hours must be like the x. So you can use that to figure out what the rate of pay per hour is for question 7, and you can do something similar for question 9. Good luck.